Today I have the privilege of announcing the new designation for the SimCenter as the National Center for Computational Engineering at the University of Tennessee, Chattanooga.
Well, the practice of engineering out there in the field has changed dramatically in the last 10-15 years with the advent of modern computing technology and the use of large computer codes.
Computational engineering is the numerical simulation of physical phenomena.
We use physics-based computer programs in large computers to essentially build a model of whatever it is you're trying to design in virtual space before you ever cut metal.
It's much easier in today's world to simulate on the computer than it is to go out and actually build something.
Whether it's blood flow in the heart or flow over spacecraft. We do a lot of work on submarines, a lot of work for the Navy.
NASA has contracted with us. We can bring computational engineering to bear on problems of national importance.
This is a world-class laboratory and group of scientists that was unprecedented in the university's history. And what it does is it engages us in research and problem solving for national problems.
Radiance Technologies has benefited in the fact that we're able now to simulate large and small antenna design. It's provided a source of research in electromagnetics.
And this is real research at a very high level. And whether it's drag reduction on 18-wheelers at U.S. Express or Covenant Transport, or whether it's new airplanes that Boeing is making.
The SimCenter's given us at U.S. Express the knowledge to be able to take different ideas and test. You know, tire, for instance, can save a lot in fuel economy. We'll buy close to $40 million worth of fuel in 1 month. And according to the calculations that the SimCenter's come up with, we can improve fuel economy by 8%. That's tremendous.
Natural resources are becoming limited. The SimCenter is developing, optimizing, improving fuel cells as we speak. We have a fuel cell alternative energy lab out back. A fuel cell is really the engine of the future.
The whole competitiveness agenda is this global question of, is the United States falling behind places like China and India in terms of science, math, and engineering? And the answer is yes, we are, and we've got to do something about it.
If China and India are educating 850,000 engineers a year, and the United States is educating 70,000, we're going to be in a mess in 10 to 15 years.
A center for computational engineering halfway between Huntsville, Alabama and Oak Ridge, Tennessee makes a whole lot of sense. Talking about competitiveness, we'll be solving problems for the world and making money at the same time.
The SimCenter, combined with the research talent at Oak Ridge, combined with the research talent at the university, is world-class.
Due to much private sector support, the tremendous partnership that exists right now between UT, Oak Ridge, UTC, causes this to be a very distinctive thing for our community, for the state, and for our country. And as we continue to try to compete in a world economy, having this right in Chattanooga, Tennessee really sets us apart.
I think my vision for the SimCenter is that we'll be producing 20 to 30 young, skilled PhDs that will go out there and make a difference.
The more we can distribute success in our science and technology and get that into society, and they can see that visible mark here in this state that is as good as anything in the world,